Now we'll see how to delete a node from the first. Okay, first we'll see deletion operation. Deleting a node from single linked list. Okay, so number one, deleting at last. Deleting at first, next deleting at last. We also can insert and delete after some particular node also. So that we'll see soon. Okay, first we'll finish this one. So deleting at first. Okay, so what we supposed to check? So before deleting this, first check the linked list is null. So okay, if head is null means the linked list is null. Okay, right? And then set head to the first node. So in our case, the head is a node which points to which is the first node. The one is the first node in our case. So we have 1, 2, 3. Na? So and that the one is the first node. Next, what I have to do, I have to set the head as the next node of the first node, which means second node. So how do you represent the second node? The next node of the first node is called the second node. That's why I mentioned as set the head as the next node of the first node. Next, what? Free the okay. I mean the so here we say it's a start, right? So here the start as the next node. Next, free the head. So set the head as the next node of the first node. Okay, right? So and next free the current head. Okay, so let's see this in a program. Okay, so now we'll see the implementation part. So what did I tell you first? Okay, so first first check the linked list is null or not. Okay, so if head is not null, just give if, right, head is not equal to null. So which means I am checking whether it is a empty. If it is not empty, what I have to do is I have to make the pointer. Okay, so here I already did the pointer is equal to head. Okay, next what I'm going to do is I have to move the uh, pointer to the next node. So pointer is equal to pointer tends to next. Next is what? Next free pointer. Okay, so this actually it is not a pointer. I should not move. I have to move the head. Head is equal to head of next. Okay, and then free pointer. So what happens is what I'm doing here. Let me just show you in the representation. So actually this is not we are going to do. We are going to delete this, and this is going to hold the null value, and it's not going to have. So this is our content. Okay, so let me just give a control S, so I don't want to disturb this program. Okay, so shift control N, control, oh, I'm sorry, so control A, control C, and then control V, and control S, which is, sorry, which is delete at first. Okay, so this is not required for us. Okay, now what are we going to do? So let's first explain the diagram. Now I'm going to delete the one. Okay, so how do I delete it? At present, this is where I have a pointer. This is what the pointer and the head, comma, head. Now this is what I have given here. So pointer is equal to head. Next is what? Next I have to move this head to the next. How do I represent that? That's what I mentioned. Set the head as the next of the first node. Which is the next of the first node? This one. So I have to move this head here. Okay. Now next what I am supposed to do? Next you have to free the not head, free the PTR. Okay. So once I free this PTR, okay, so the PTR will be deleted and this will be deleted. Okay. Only the node 3 and node 2 will be there. Okay. Now this is the head node. Okay, and this is the next node of the head node. Okay, this is what the logic that we are going to write in our program. Okay, now we have defined pointer is equal to head. Next I have to move the, so if I have to check if head is not equal to null. Okay, so if it is not null, just move head equal to head of next, head equal to head of next, right? Next what I have to free the pointer. Okay, so this is what you're supposed to do. Now if I run this code, so before doing this, let me just comment this and let me show you what is the content of the file. Okay, I want to show you what is the content of this file. Let me just comment this one. Okay, so I commented. Now if I run it, okay, it will tell you the content of the node, okay, which is 12267. So according to our concept, we have to delete the 1. Okay, so now I remove this code, then it will give you a run. So now see, the 1 is deleted. Okay, so this is what the deletion happens at first. Okay, now we'll see how to delete at the last. Okay, so what is the algorithm for the delete at the last? So as usual, first we need to move the pointer to the next one. Okay, next I have to make the, so where I find where will I get the null value? I'll get the null value at the last, I mean the pointer to the next. Okay, the point to the next, if the point to the next is null, that is the last value. Okay, till then I keep moving, right? So once I found, okay, so I have to make the previous node as the last node, and then I have to delete the pointer. So here we need to do it. Okay, let me just, so this is what we have done for letting a first one. So let me just give a control set and let come back to the same position. So I'm undoing it. Okay. So this will delete here PTR. The same way we are going to have one previous pointer. Okay. So we are going to have the previous pointer. Why do we need this? Previous pointer comma pointer. Okay. So at the beginning it will be like this, right? When come to the next iteration, okay. So I have to keep moving the pointer. When I keep moving the pointer will move here. Okay. The pointer will move here. In the next iteration, let me just copy and paste it because it's required. Okay, now once a PTR moves here, right, this also moves here. When the PTR comes here, what's the next of the PTR? It is null, right? Okay, so it stops here according to our algorithm. Okay, so we have to move the PTR until it finds the node which has a next as null. Okay, so it finds a null here, so the PTR stops here. Now what I have to do is, now I have to make this previous PTR of next as null. Okay, right? So in the next iteration, let me just paste it again. In the next iteration, this is going to be null. Okay, this is going to be null and this will be freed. Okay, this will be freed. Once I free this will be going out. That's it. Okay, now the list, now the 66 is 67 is deleted. Got it? Right? This is how we do it. Okay, creating a node. Now we'll see how to do this in a program. Fine. So I have to create a one more pointer, right? So what is that? That's supposed to be a previous pointer of the same type. So struct node star previous pointer. Okay. Next, what am I supposed to do? So if head is not equal to null, okay. So head is not equal to null, then while I have to move PTR, right? While p pointer while pointer of next is not equal to null, which means I am traversing till I get the node whose next is null. Okay, so this is what it does. So in the first place, whenever the pointer moves, right? So before I moving the pointer, I have to equalize that pointer with the previous pointer. So that's why I give previous pointer is equal to the current pointer. Next, I have to move the current pointer is equal to pointer of next. Okay. So once it comes to the null position, right? Once it comes to the null position, it will take the data. Okay. So it will take the same pointer, then pointer of next equal to what? Null. What pointer of next? The previous pointer. Because I told you, right? previous point of next is equal to null, which means that will after making this as null, I have to free the pointer. Okay. So if this is done, you'll see a 23 will be deleting. I think I missed a semicolon here. Yeah. Right? 67 is deleted. This is what deleted the last. Okay. Now we can see how we can insert an element after a specified node and how to delete an element after a specified node. Okay, that also possible. So let me just copy, save it. Let me just copy this and then we'll paste it. So insert after a node. Okay. So if you know this means you can use it in any concept, right? So first, if you understand the traversing of the linked list, right? Okay, then everything will be easy. The stack, a queue, because we are going to implement the stack using linked list and a queue using linked list. Okay, right? So how can I insert a data? So first, to represent that, right, we need the data. We need this one. We need all these four. Okay, so what are we going to see? We're going to see insertion and deletion after a node. So let me just copy this one. Now what I'm going to do is I want to insert the data, okay, after 22. So which means after inserting a data 22, how the list will be, it will be something like this. Okay, let me just move this to some point and let me keep this here. I think I have to take this line, take this line here. Okay, right. So let me group it here. Okay, it is grouped only. Right. So I have to make this down here. But I'll delete it. So first you will be having one. So I have to link. I want to insert the data after 22. Okay. Next I have to take the arrow. Okay. Now I have to link the new node of next is the it will be like this, right? So I need to okay. Let me just take this arrow. right? So this is how I can link it. So which means I want to insert after the 22. So insertion delete after the node, which means the node 22. Okay, after 20. That's why I mentioned here. So I have to make this new node 23 as a next to the 22, and the next of 23 must be the 67. Okay. So how do I represent the 67? How to represent this one? So this we need to do it very carefully. Okay. So what is the algorithm? First, we'll see for insertion. So inserting a node after a given node algorithm. Okay. The first step. Okay. So initialize the pointer. Initialize the, sorry, create the pointer. Okay. Create the pointers. Okay. Create the pointer. One is pointer. Other one is previous pointer. What is the next one? Next, get the data to be inserted, right? Next, get the data of the node after which the node can be, okay, after which the node can be after the new node can be inserted. Okay, right? So next, create new node, right? Then assign the value to the new node. Okay, right? Next, check the previous pointer is having the having the uh, having the node value. Okay, get the data to be inserted, which means let me say it's a value. And having the node value. So in our case it is 22. Okay, base pointer having the node value. Okay, and keep moving the pointer. So check the previous pointer having the not having the node value, not having the node value, and move the pointer. Okay, when the pointer moves, the previous pointer also moves. Okay, right. And then just print the result. The before that, before that, what we have done. So for suppose first I'll check with. I want to check the 22. Check whether it is 22 or not. If it is not 22, please move it. Okay. Now check if it is 22 or not. Yes, it is 22. Okay. So once I found that, so now the previous now at this place I have both my at this way I have both my previous pointer and pointer here. Okay. So once the pointer moves to the next, okay, the next, the previous pointer will be stay there. So next what happens? Next what happens? So it will go to the next point. Am I right? So which means it will go to the, before I am making a link, what is the next to this 22? Next to 22 will be this one. Okay. And once this pointer moves, the previous pointer also moves. Okay. Right. So which means right now the pointer points to 67. Now I check the previous pointer is not having the node value, but my previous pointer having the node value, which means it violates. Okay. So once the condition stops, it comes out of the loop. So after it comes out of the loop, what I'm supposed to do? I have to the make the new node as the next node of the previous pointer. Okay, right? And the next of the new node as a pointer node, which means this is a new node, am I right? Okay, so the next node of the previous pointer is new node, and the next node of the new node is a pointer. Okay, this is how I can make the link. Okay, now now we'll see how to do this. So insert after a node I have taken, right? So we created a pointer, new node, everything we created, right? So and then first we need to go as per the algorithm. So what the first our algorithm says? Algorithm says that create a pointer, previous pointer. That we already done it. Okay, so we created pointer and previous pointer. Okay, right? Why we are not allocating a space? Because for a pointer we are not going to allocate a space. We are going to represent it. Okay, so for that a space is not required because we're not going to store anything in the previous pointer or pointer. That's why we are not going to use it as a node. We are going to just use it as a pointers to move it. Okay, right? So now assume that this is the new node, okay, which is to be inserted. Okay, this is a new node, the value to be inserted. So this is the value to be inserted after a 22, after the node 22. Okay, right? So next, now we know what is the node which you are going to say. For example, int value. This is the node after which I am going to insert. Okay, right? Now what's our point? I have to I have to create new node. So yeah. So now at this place, the pointer is pointing to the head, right? Next, the previous pointer must point to pointer. Okay, it's like making connection. The previous point, the head. Before that, there will be a pointer. Before that, there will be a previous pointer. Okay, right? Now, both the head pointer and the previous pointer, it's all in the same place. Okay, it's at this place. Okay, so at this place, the head, previous pointer, comma, for your understanding, just typing it as a pp. Now it's all in the same node. Next, what am I supposed to do? I have to use the while loop. So what I have to check? So as per our requirement, it says that so we have done assign the value. We created a new node. So using mlog, we created a new node and we assigned a value to it. Now I have to check the previous pointer is not having the node value. So while the previous pointer of data, okay, it's not equal to val. So what's our value? Value is equal to what? 22. Because after 20 we are going to print. So once it is not a value, next assign the previous pointer as pointer, and then pointer equal to pointer of next. Pointer is equal to pointer of next. Okay, which means it keeps moving. So once it is false, which means it is at the, now once it is false means now the PTR is pointing to the next value at this point. Okay, right? So once it is done, right? Now the previous pointer and pointer will not be there, so it will be here. Now the previous pointer is having the value 22, and the pointer is the next. Okay, so right now I just remove the link, that's why you can't see it, but it's having a link. Okay, right? After this only. Okay, so for your understanding, let me just take this as previous one. Okay, so it is for understanding, so nothing wrong in taking the effort. Okay, so right now let me just pull this. Let me just pull this here. Okay, so this was a link, right? So right now this is where my previous pointer, and right now this is where my pointer is. Okay, so as per my while loop, okay, now the previous pointer value is equal to the value, okay, the data of the previous pointer, and the value which I'm searching is matching, so which means this condition is false. So once this condition is false, what I am supposed to do, I have to make the previous pointer of next, okay, the previous of next equal to new node. Okay, and then new node of next is equal to pointer. That's it. So while head is not equal to null, okay, not equal to null, it traverses the list. So what happens? So we are making the previous node of next as the new node, and new node of next as the pointer. Okay, so let's check how it works. Are we getting 23? Yeah, so we are getting after the 22, we insert the 23. Fine. So this is how we insert data after any node, the linked list. Okay, the same way, let me do it for deleting it. How do I delete it? Delete after delete after node. Okay, in the same way here also we need all the stuff. So the same way the diagram represents, right? So it's gonna be little different. So now the deletion, right? So deleting a node after a given node. Okay, algorithm. So this also same, but what's the difference is here we have linked the next node of previous pointer as the new node. Okay, now what we supposed to do is, suppose I'm going to delete a 22 means I have to link that one with 67. Okay, right? So I have to create in such a way that like this. Deleting a node. So before running algorithm, so if I give you a picture, it will be better. So I have to remove this link, and this link. So how will I remove? I have to first create a link with 1 and 67, and then so I have to create a link, right? So this is what I have to do. Then I have to free this. Okay, so how will I create a link like this? Very simple. Just think. The next of this one is the next of this 22. Am I right? So the next of the one is linked with the next of the 22. What is 22? So 22 is a pointer. Okay, and what is 67? 67 is a pointer of next. Okay, so the current node next must be the pointer of the next node. Okay, so we have to use the same pre-PTR, PTR, same representation. Okay, so how do I give this one? So we have to define this as pre-PTR, previous PTR, comma PTR. Next we have to define the temp as well. Okay, because temp is used to delete and plus element 22. Okay, now I want to delete the 22. So what is the algorithm first we need to do? So the same as usual, right? So let me just copy and paste. Let me do a simple modification. Okay, in the algorithm it is same. So just add PEMP. Okay, and here I want to get the data to be deleted. Data to be deleted. That I want to do. Okay. Next, I have to assign the pointer to the head. Assign the. So now we are not going to create anything. Assign the pointer to the head. Assign the pointer to the head. Next, I have to move check, right? The previous pointer is not equal to the node value, which we are going to delete. Okay, not having the node value, which we are going to delete, and then move the pointer. Okay. Next, make the just assign the next of the previous pointer to the next of the pointer. Next, free the temp. I mean, free the. Okay, so because of pointer, the temp is not required. So I think I only just given it. I thought we can use a temp. Now, if we delete the previous pointer itself, we can it because this will be the pointer. Temp is not required. I'm sorry. So the pointer will be here. So if we free this, then everything will be fine. Now, how do we implement this in a program? So we have a previous pointer, and then next we have to do this. Yes, right. And the previous pointer is equal to pointer is equal to pointer of next. This is all same. So what is the only change? So the previous pointer of next is equal to not a new node. Now it's going to be a pointer of next. Okay, pointer of next. That's all. Next, I have to free the pointer. Free the pointer. Let's check. Plus 322. This later one. So I want to check. Yeah. So now we write 22. So pointer value. So what is the value that I'm going to delete? I'm going to delete the 22. Right? That's what I given here. So previous pointer. So in this place, I have to make the pointer as a start. Is it B? I have to make the pointer as, yeah, the pointer is equal to the starting node, that is a head node. And then the previous pointer is also pointing. The previous pointer of data is not equal to val. Yeah, it's working fine. So why it is not coming? So if I run this, it's supposed to give 167. So what it is doing, it is moving as per this one, as per our plan. It checks the previous pointer not having the value. So when this pointer, when this PTR moves here, it has to check whether this is having the value or not. Okay, not this previous pointer. Yes. So now I have to make this as not a previous pointer. The pointer value. So this is sorry, not this one. Check the pointer is not having the value or value. I think if it works, it is fine. Let me just use of previous pointer. Let me check it's a pointer. Save and run. Yeah, it's deleting. Okay, fine. So yes, just try this. Temp is equal to pointer. Even if you normally, if you give simply pointer, it deletes, no problem. Okay, so this is how I can delete after the node, after a given node, and delete after the first node.